In this vision of the material, which is in a certain sense an halfway between engineering, material engineering and solid-state physics, in these visions, the mechanical tests and measures are to be performed at a smaller scales. In fact, in this picture, you see the mechanical characterization of the single constituents, the mortar, the stones, and some tests of very small assemblies. And then all the mechanical information is transferred by theoretical reasoning to the higher scale, at the scale of the structural element, aiming at evaluating stiffness, strength, and ductility. All these structural elements cooperate to define the building behavior. Stone is massive, and this implies that stone construction is very sensitive to seismic action. The seismic force would imply a strong nonlinear behavior of the structures, and would require not only strength but also ductility. In this picture, you see a representation of the ductility requirement of the seismic force and of the ductility reserve of the building. The buildings is modeled like a box. Ductility and strength are required also to each single structural element. For example, this is an example of a masonry pier, and in this picture you see the equilibrium chord of this masonry pier in the outer plane behavior versus the interface shape. Strength and ductility of this pier depend on many factors. First of all, the wall slenderness, the real or strained state of the wall, the mortar stone cohesion, the shape of the interface between blocks. Outer plane behavior of masonry panel is under scientific debate. Just some words about mortars. Cement mortars damage. Sorry. Okay. I'm sorry. The damage of the cement mortars against the stone are very well known in the field of restoration and conservation of the cultural heritage. This depends on the fact that cement is full of soluble salts. These soluble salts are the cause not only of anesthetic efflorescence, but also of disgregation of the stone itself. In fact, this salt, in humid environments, this salt dissolve and circulate within the pores of the stone. When the water evaporates, they crystallize and they increase their volume, and this increasing of the volume causes the disgregation of the stone itself. Moreover, cement mortars are less resistant to acid rains because the trichalcic aluminate interact with the sulfurous anhydride and form another soluble salt, which is the calcium sulfaluminate. Moreover, cement mortar have a permeability very less than stone, And so, for this reason, at the interface between mortar and stone, arise a watertight contact, which favor detachment between stone and mortars. A rapid mention about the use of polymers with, for structural adhesives of the stone. Some attempts have been made in the past, but the question is the scientific and technological debate is still open about some drawbacks. For example, the low duration of the polymers and its very low permeability. In conclusion, I tried to sketch which could be some future development of stone construction, in my opinion. One of the themes of sustainable design pertains to the energetic self-sufficiency of the buildings, and a significant percentage of the energy consumed of the building is spent to ensure thermal comfort to people inside. One way to limit transmittance of a wall is to use materials characterized by low thermal conductivity, like stone. Moreover, stone mass means also acoustic inertia, and this implies building acoustic insulation. This means that stone is a good material for civil construction. Other considerations. Mining and stone manufacturing in Europe are active economical sectors, but characterized by a high environmental impact. High percentage of stone are considered quarry remains and manufacturer remains. All this means because they are full of flaws, and so they are considered unsuitable for coverings or permits. All this means high production costs, high waste of energy, and waste of materials. The modernization of the production cycle by the development of the innovative technologies of extraction and the new cut lines for the use of stone with flows, like construction material, would represent a good synergy. In some cases, this is exactly what's happening now. Thank you for your attention.